Hello dear student friends, I am again back with a new video. This time the video is on measures of dispersion. This is one of the important topic in biostatistics in the theory as well as in the practical. Now let us see what are the various measures of dispersion. Suppose if we perform a study and we take the blood pressure of uh, people, a large group of individuals. So what we'll see that each individual will have a different blood pressure reading. So it will vary from one person to person. That may be possible that a blood pressure of one person in the morning will be different and in the evening will also be different. So these differences in the observations of the blood pressure of individuals is called as variation in the blood pressure. So this variation or these measures of dispersion help us to find how individual observations are dispersed around the mean. So whenever we find out the dispersion, it is around the mean. So mean has to be calculated, and from that we need to find out how much is the dispersion of the observations from the mean. So these are also called as measures of variation. So we have two terminologies. One is measures of dispersion and measures of variation. So sometimes in the theory exam, they ask you a short note for 3 marks, or in the practical examination, they ask you to calculate 1 or 2 or 3 measures of dispersion. So let us see how we can go for the calculation of the variation. So what do you mean by normal variation and how we are supposed to measure the variation in the observation? So in this video, we are going to see about the measures of dispersion. So these are the examples of the measures of dispersion, starting from the range, mean deviation, standard deviation, interquartile range, and coefficient of variation. So mostly in the exam, practical exam, they ask you either to calculate range and standard deviation, or sometimes they ask you to calculate mean deviation and standard deviation. Actually, mean deviation is the part of calculation of the standard deviation. So most of the time they ask you to calculate the range and standard deviation of the given data. Sometimes separately they also ask a question on coefficient of variation. Interquartile range, very rarely they ask the question. So now coming to the first measure of dispersion, that is range. So what is range? Most of the textbooks I have seen that they write that range is the difference between highest and the lowest values. So what is this difference? So in this picture, you can see that ages of students are given. So age range is from 13 years to 16 years. So how they have calculated here range, that highest minus lowest. So 16 minus 13. So can we say that the range is 3? I think no. So actually the range is 13 to 16 years. So it is not the difference. It is the value or observations including the lowest to the highest. So most of the time range is expressed as from lowest value to highest value. Now take the another example of hemoglobin of males, normal hemoglobins. So it is from 14 to 16 gram %. So now here we don't take difference. Most of the time I ask in the Viva the range of normal hemoglobin, if particularly when a student is presenting a case of anemia. So they never say that the range is 2. They say that the range of normal hemoglobin is from 14 to 16. So it is the from the lowest value to the highest value is the range. Sometimes they take the difference. So try to write down the lowest value to the highest value. So range is the simplest measure of dispersion. In group data, the range is the difference between the midpoints of the extreme categories. Range has little practical importance, so very rarely it is being used. It only indicates extreme values, means lowest and highest values are indicated by the range, and nothing about dispersion of values between extreme values are given by the range. Now coming to the interquartile range. Now range you have understood, it is from lowest to highest. Interquartile means uh, between the two quarters. So quartile terminology has come from the quarter. Here you can see that first 25% is quarter one, second 25% is quarter two, third 25% is quarter three, and fourth is the last quarter four is 25%. So first quarter is at 25%, third quarter is at 75%. So when we take the interquartile range, it is the difference between the third quarter and the first quarter, that is Q3 minus Q1. So interquartile range is the difference between the upper quartiles, quarter one, and the lower quartiles, that is quarter three, that is Q3 minus Q1 is the interquartile range. The series of observations is divided into two parts by the median. So in each quarter, there will be one median, and that will divide that quarter into two parts. 50% of the observations will be above the median, and 50% will be below the median. So interquartile range is the range between the median of first half and second half of the quarter. Now let us see this with the example of this example. Now here you can see that there are two halves. One is lower half and second one is the upper half. So what is the median for lower half? The middle value, that is 52. And what is the upper median for the upper half? That is 58, middle value. Or you can say here it is the third value of each half. So in that case, we need to take the addition of the median of the first half plus the median of the second half. That is 52 plus 55. Or you can say it is 53 plus 55 divided by 2. So Q1 is 52 and Q3 is 58. So in this case, Q3 minus Q1 is equal to 58 minus 52. So like this, we can calculate the interquartile range. So you need to find out the what is the median for each half, and then you have to find minus or take the difference of the Q3 minus Q1. This interquartile range is very rarely asked in theory also and in the practical. So that's why it is not that much important. But the mean deviation and standard deviation and also the range are important. Now, this is another example of the showing the difference between Q3 and Q1. So here you can see that this is the Q3. So here at this point is the Q3. So we from this, so there will be almost 75% observations, or 75th percentile will be the Q3. So from this we minus the first quarter, that is 25th percentile. So this will remain as the middle 50% of the observations. Now coming to very important is mean deviation, because standard deviation calculation will also depend on mean deviation. So a name itself suggests that what is the deviation of the observation from the mean. What is the deviation of the observation from the mean? It is called as mean deviation or deviation from the mean. So what is this? It is the average, or it is also a mean of the deviations from the arithmetic mean, or it is the arithmetic mean of the difference of each observation from the mean. So we need to do take the difference. You can say that if the single observation is 25 and the mean is 20, so 25 minus 20 is equal to 5. So that is the difference. So we have to take the difference, the mean of all these differences. I will show you one example. So both negative and positive differences are treated as positive. And when we take the difference of the observation and the mean, sometimes the values, they come in negative sign. So we need to ignore them and we have to take them both as the positive. So what is the formula for calculation of mean deviation? That is summation of the difference of the observation and the mean. Or you can take the example here that x1 is the first observation. So we have to take the difference minus the mean divided by n. So this will give us the mean deviation. So here you can say there is a summation of the difference from of the observations, like first, second, third, to the n number of observation from the mean by divided by total number of observations, that is the n or sample size. So now we will see how to calculate the mean deviation. So they will ask you to calculate mean deviation and standard deviation for the given data. So what data is given? That they have given 7 observations: 6, 6, 3, 8, 10, 9, 7. So so total number of observations are 7, and if you make the total of all these, it will become 49. So what we have to do? How first we have to calculate the mean, because mean is not given, only observations are given. For calculation of mean deviation, we need the mean. So first step is to calculate the mean for the given data. So here the total is 49 and number of observations are 7. So we need to divide 49 by 7. So mean for these observations is 7. Now we have to calculate the difference between the observation and the mean. So here you can see these are the observations which are given, that is x. So this is x1, x2, x3, x4, x5, x6, x7, like this. And this is the mean. So we have calculated mean as the 7. Now we have to take the difference, that is x minus x bar. So 6 minus 7 is minus 1. 6 minus 7 again is minus 1. 3 minus 7 is minus 4. So here you can see the observations or differences are in the minus. So we need to take them as the positive only, even if it is negative. Then 8 minus 7 is 1. 10 minus 1. Likewise, we got these differences in the observations. So what we have to do now, we have to take the summation of all the differences of the observation from the mean. So the total has come to 12. So mean deviation is equal to summation of x minus x bar by n. So it is the difference of the observation from the mean. So x minus x bar by n. So how much is the x minus x bar here? Is 12 summation, and divided by 7. So like this, 12 by 7 is equal to 1.71. So mean deviation for this given data is 1.71. So we have to ignore the signs plus or minus. Now coming to the standard deviation. So standard deviation, it is an important over mean deviation because it is the pure measure of dispersion, and it is most commonly used in statistical analysis, particularly in normal distribution and normal distribution curve. Sometimes they ask you the definition, define standard deviation. So it is the root means of square of deviation. So we have seen mean deviation. So we have to take the root of the square of the means of the mean deviation. So, and this standard deviation is denoted by the Greek letter sigma or by SD. Now, what is the formula for calculation of the standard deviation? It is standard deviation is equal to the square root of the summation of the square. Now you can see here square of the mean deviation square. When this formula is used, if the sample size is less, if the sample size is less than 30, it is called as the small sample size. So we have to take here in the denominator as the n. Whereas if the sample size is less than 30, if the sample size is more than 30, n we have to take. If the sample size is less than 30, we have to do n minus 1. So whatever number of observations are there, we have to minus 1. So this is the formula for calculation of the standard deviation. So here you can see it is the root. You can see here it is the root of whole. Actually, this whole comes into the room, and it is the mean. We have to find out the mean of the squares of the deviation. So we have to take them. These are the squares of the deviation, and if we divide it by number of observation, it will become the square of the mean of the square of the deviations. So like these two formulas are used based on the number of sample size. Now coming to the steps involved in the calculation of standard deviation. So first step, they will again give the same data. Calculate the standard deviation for following data. Mean will not be given. So first step is to calculate the mean from the given data. Then find difference of each observation from the mean, that is x minus x bar. And after this, we have to take the square of the differences, or square of the x minus x bar. After that, we have to do the summation of the x minus x bar square. And then we have to divide this summation of the x minus x bar square by either n or n minus 1. So like this, we can calculate the standard deviation by taking the square root of all these observations. We have to take the square root of all, then we will get the standard deviation. Now, let us see one example. The same example we will follow here, for which we have used for mean deviation. 7 observations are given. Total is 49. The mean is 7. Now, this also we have seen that the summation of observations is 32. Here you can see one more step further we have gone, that we have taken the squares of mean deviation. X minus x bar is the mean deviation, and we have taken their squares. So square of 1 is 1, square of 1 is 1, square of 4 is 16. We have to consider it as positive only. 1 is 1, 3 squares is 9, 2 square is 4. And we have to add. So what we have got 32 is the summation of the square of the mean deviation. Means we have taken the square of the mean deviation. Now we know the formula for calculation of the standard deviation is summation. First we have to find out the mean of summations. These summations we have got, its mean will be calculated by dividing this summation with the number of the sample size. So x minus x bar square divided by n minus 1, because the sample size is less than 30. So we need to n minus 1 should be taken as the denominator. So 32 is the squares. Divided by 7 minus 1 is equal to 6. So it comes to 5.33. So up to this step, we have seen the summation of the squares, or you can say it is the mean of the summation of the squares of the mean deviation. Now we put all these values or this figure into the square root. So this is the square root of the squares of the mean deviation, or squares of the mean of the deviations from the mean. So we have to take the square root of 5.33, that comes to 2.3. So the standard deviation in this example is the 2.3. So here you can see that first we need to calculate the mean, then we have to calculate the mean deviation, then we have to take the squares of the mean deviation, and then we have to take the summation of the square of the mean deviations and divide it by the number of observations, and then we take the square root of this observation. So square root of 5.33 is 2.3. So like this we get the standard deviation. So please don't get confused. Follow the steps. Almost there are 7 steps in the calculation of standard deviation, and first 3 to 4 steps are there for the mean deviation, and after up to this is the mean deviation. After that we need to take the squares, we take the summation, then we calculate the mean of the squares of the differences, and then we take the square root, and like this we find out the standard deviation. So what is the significance of standard deviation? In short, I will say that if there is a larger the standard deviation, it means there is a more variation in the sample, or if the standard deviation is smaller, it means that the variation or dispersion is less in the given observation. So here you can see that there is a less deviation in this, so the figure will be like this, and there is a large deviation, so there will be more dispersion in case of the large standard deviation samples. Now coming to the last part of the measures of dispersion is coefficient of variation. So coefficient of variation, why we calculate? We need to find out the variation between the two given data. So in that case, we go for calculation of the coefficient of variation. So it is, what is the coefficient of variation? It is the ratio of standard deviation and mean. Means we need to divide the standard deviation by mean and take the percentage. So whenever we take percentage, we have to multiply the formula with 100. So coefficient of variation is always we express in terms of percentage, and coefficient of variation is the ratio of standard deviation to mean multiplied by 100. So it is useful to compare the variation in two groups of observations, especially if the units of measurements are different. So we can compare between two groups and we can find out the variation. Now here I have given a very simple example of calculating coefficient of variation. So what we need to calculate the coefficient of variation? The mean and the standard deviation. So what they have asked us, calculate the coefficient of variation for a sample with the mean 100 and standard deviation 2. So write down the given data, that is mean is 100, standard deviation is 2, and we need to calculate the coefficient of variation. The formula, write down the formula for coefficient of variation, that is standard deviation by mean into 100. So 2 by 100 into 100 is equal to 2%. We have to express this in terms of percentage. So in this example, coefficient of variation is 2%. Now coming to another example, which is commonly asked in the exam. Comment on the variation of two samples having standard deviation 2 and 5 and mean 50 and 100 respectively. So first mean is 50 and first standard deviation is 2. This is for one sample number 1, and for sample number 2, mean is 100 and standard deviation is 5. What we need to calculate? We need to calculate the coefficient of variation for both the samples. So we will get the coefficient of variation for first sample and coefficient of variation for second sample. So we have to put up the values in the formula. 2 by 50 into 100, that is 4%, and coefficient of variation for second sample is 5 by 100 into 100 is equal to 5%. So which sample has more variation? The second sample has the more variation. So like this, we have to calculate the coefficient of variation and we have to comment on. So this is all about the measures of dispersion. Please remember that range, mean deviation, and standard deviation are usually asked in the practical examination. Or you may get a separate question like this in the practical examination for commenting on the variations between the two samples. So I hope that you will understand this video. Please try to view this video repeatedly so that you understand particularly the topic of standard deviation, because they're a little bit confusing. So please go through this video, try to learn the range, mean deviation, standard deviation, and coefficient of variation, and do the practice on paper, because sometimes we get confused while solving in the exam. So in biostatistics, doing calculations on the paper is very, very important because that will make you perfect. That's why I said that practice makes us perfect. So please do more and more practice for mean deviation and standard deviation. So this is all about the measures of dispersion. Thank you very much.